So you remember what this is, right?
Mm-hmm.
Acid halide. How about this one? Remember what this one was?
Anhydride.
Perfect. This one?
Carboxylic acid.
Cool. And how about this one?
Ester.
Yep. How about this one?
Anamide.
Okay, amide.
Amide.
And how about this one? Starts with an N.
An N.
Mm-hmm.
And nitro.
Nitrile. Okay, so we had said that in terms of reactivity, if we go in this direction, oh, it's a little bit bright. If we go in this direction, we're becoming more reactive. We talked about this, right?
Mm-hmm.
And also, when we go in this direction, we get less stable, right? So this compound is less stable than the ones on this side. It's also more reactive. And this group here, so the group to the right here, and here, and here, and here, and here, and this one is kind of weird, right? So this guy is weird. But the group to the right, these are going to be our leaving group.
Okay.
Right? And as we go this way, the leaving group is better. Right? So we kind of touched on the reaction scheme of these reactions, of the carboxylic acid derivatives. So all these guys here are carboxylic acid derivatives. So the acid halide, anhydride, the ester, the amide, and the nitrile, they're all carboxylic acid derivatives. So they undergo a substitution reaction. Right, so they're going to undergo a substitution reaction. Alright, so they're going to undergo a substitution reaction, and the substitution reaction can occur under two conditions. So it can occur in basic condition, right? Or it can occur under acidic condition. Right, so you're going to have to know the mechanism for this one. You need to know the mechanism. You need to know the mechanism for this. But This one is going to be the has a shorter mechanism. This one is going to have the longer mechanism. Right? Now this is what we're going to say. We're going to say that for the basic condition, we're going to say that for the mechanism for this, two things is going to happen. The first thing that's going to happen is that the nucleophile will attach, and the second thing that's going to happen is that the leaving group leaves. And we touched upon this, right? Right. We're going to say that the same thing is going to occur Alright, so we're going to say that in the acidic condition the same thing is going to occur, but we're going to sandwich it with protonation, deprotonation. So we're going to get one, we're going to get another stack here. So we're going to get protonation, deprotonation, we're going to try to make this fit. So we're going to get a sandwich of protonation, nucleophile attaches, deprotonation, then we get protonation, right? And you can guess the last one will be a deprotonation. Alright, now what's getting protonated here is the carbonyl oxygen. Right, what's getting deprotonated here is the nucleophile. What's getting protonated here is the leaving group. And what's getting deprotonated here is the carbonyl oxygen. It's going to have a hydrogen attached to it. So this is how the mechanism is going to look like, right? And we'll just do an example of this. It's really fast. Do an example of this. Alright, let's say that we have, this is a generic carboxylic acid derivative, right? N can be, right, let's just say this is a leaving group, right? And this is the nucleophile. Cool. And the leaving group could be any of these guys here, right? Right? And nucleophile, just a random nucleophile. And in the basic condition, the nucleophile is going to attach. And the way it does that is it's going to attach here, right? Because this guy is partially positive, partially negative. This electron will swing up. The reaction is going to be in equilibrium, so we use these double-headed arrows. The nucleophile will be here. This will be the leaving group. This is called our tetrahedral intermediate. Right? And this electron comes back down and kicks off the leaving group. So that's the second part, right? So the nucleophile attached, we form the tetrahedral intermediate, then this electron swings back down and kicks off the leaving group. So the leaving group leaves. And then we generate our product.